Well, we're gonna see a video, a longer one today. So that's the reason why the setup is according to that video. So there might be some interferences with my talk, actually. We don't know that. But let me say a few things about last week. Number one, I am sorry if I was I was showing a little bit nervousness during the exam, especially when you were asking questions to me. Because you see, at some point, you started asking questions which were not very reasonable. You were asking me, is this 2? Or do you have like did you write 5 here? Something like that. So, or some people, as usual, was trying to show the work that they have done and saying that this is the way that I did. Is it correct? Okay, so you can see that it is not useful actually to answer those questions. Moreover, I always feel that the less questions you ask, the more concentration you're going to have. The worst part about this issue is that you're not only disturbing yourself, but you are also disturbing your friends that are sitting in your vicinity. Okay, and I think that's very crucial. Because if you look at carefully, make an observation. Let's say that there is a question coming from there, and then in the exam you can make sure that in 5 minutes, some people around her are also going to ask questions. Because that's the way that it goes. So that was the reason why I was showing a little bit nervousness so that it will stop, but it may hit some of you, so I'm sorry about that. But still, I wasn't nervous. I was a little bit showing it off because I didn't want you to ask any questions, okay? So that's the crucial part. Now, of course, you may have certain questions that you may want to ask. So if we can be a good group of people, we will only ask questions when it is really necessary, okay? So we have to be able to guess that. Number 2, okay. Number 2, I think an important issue here is I was very happy with your performance in the exam in general. The way that you looked, you sweat. Some of you had red faces when you were going out. This is actually what I want. I want you to give as much as you can, rather than reading it and saying off, poof, or whatever, which are some cultural words. But I think this is good, because that is one of the purposes of the exams. You have to be able to put your knowledge to the exam. Now, the exam was not a very difficult one. I think you would agree with me. Although it doesn't necessarily mean that you will be able to solve everything. Okay? But I think it is a reasonable exam. And I might have a little bit more difficult exams or more difficult exams. We're going to see. It depends on my mood the night before, because I always prepare questions the night before. Actually, this time I prepared the questions Wednesday morning. So, because the night before I was too tired to prepare questions. However, this is the way that it goes. You can see that the exam were pretty clear in the sense that the things that I wanted were more or less straightforward if you followed the course. Now, I know that there might be some problems with respect to the English and so on, but that will always happen. We're going to have actually a course about that in the near future. How are you going to basically use your phrases and so on and so forth? These are the things that are not necessarily related to engineering, but it turns out to be very important for modeling. We're going to have that lecture probably in 2 or 3 weeks. Okay, now, any questions that you want to ask me? This is atonal music. Do you know what atonal music is? Like our ears are used to tonal music, which means that there is some kind of a melody. Now, this is atonal, which means that, but it is a very good music for modern dance, actually. Just keep that in mind. That's the reason why I'm doing that. Okay, any questions? Okay, now today we're gonna start watching a video. This is half commercial, but we are going to see the manufacturing of mini automobiles. Do you know mini cars, am I right? These are like English brand. They are made manufactured in Britain mostly. We're gonna have a 22-minute video, but I'm going to cut the video in between ask you questions, and that's the way that we're gonna pursue. And then after the video, we're gonna have some discussion. This is the third example that you are going to see from different systems. Remember the examples that you have seen: rice cooking, okay, airport, and this will be the third one. Okay. Okay, this is the largest size that we can get, Emre? Okay, yeah. Okay, I'm sure that you will be able to hear everything, but please be quiet, at least in the beginning, so that we will be able to understand the volume. This is a video which is available in the library, of course.
This is the factory near Oxford where BMW make the new Mini. They're going to show you how to make it. Looks like a free sample.
Okay, you will be hearing this woman all the time, so get used to her English.
Kapat. Pilini bir değiştireyim hocam.
Set up a new standard in Jeep metric.
The Mini is a brand name that's been around since the late 50s. A lot of wrinkles see the old Mini as a symbol of a time when they were not wrinkly. In 2001, BMW launched a new Mini. It's a bit like the old one. It's bigger and flashier and 21st century. It's made here in a vast manufacturing plant in Cowley, Oxford. In the old days, they just used to make cars and sell them afterwards. These days, car makers like BMW make their cars to order. In other words, they don't make a car unless someone's ordered it. Orders are placed at dealers all over the world. Once they've been processed, they come here, up to 1,000 a day, and they're all different. There are 3 basic types. There's the Mini one, the Mini Cooper, and the Cooper S. But there's loads, literally thousands of different variations. That's why every Mini made in this plant is made to an order. And every order has to be right. That's where production planning comes in.
Okay, I think it's a good way to stop here. So we're talking about mini automobiles, which have the shape. You are probably familiar with the shape. And it is known that they have different colors. And it's particular about the automobile that we're talking about. If you remember in one of the previous, when they were showing history, there was a line of automobiles sitting there. That's an assembly line, where at each step of the assembly line, they place another part to the skeleton of the automobile. So at the end of the line, the automobile is going to be ready to, almost ready to go. So this is actually the idea of the assembly line. And most of the ideas are based on the Ford innovation, the innovation of Henry Ford in the beginning of the 20th century. So that's the idea, but there has been a lot of changes, of course, in the last 100 years. But the idea is simply assembly line, which is a flow line. It's simply flowing. It is basically a line that moves. So everything at the top of it, like an automobile, is going to move in a certain speed. And the workers or the employees are required to complete their operations at some point in time, because otherwise they will interfere with the next operator's movement. So when you adjust the speed of this line, you have a certain throughput, number of cars per day coming out as long as the line flows. So that's how you can make sure that you can manufacture the quantity that you want. This is number one. Number two, she talks about a notion which says BMW. Now, I think Mini is part of the same conglomerate as BMW. I may be wrong about that, but that's the reason why they have BMW here. Otherwise, they wouldn't mention that. So it is the same company. The parent company is the same. And they talk about we never manufacture to stock. We always have somebody asking for this automobile. At that point, we start to manufacture them. So this is one of the lucky cases where you manufacture and you know the customer. So the customer would be somebody or the group which is selling Minis, for example, in Turkey. They will order 25 cars, and similarly, they would collect all the orders from different countries and start production. However, life is not that simple. Let's say that you are manufacturing these pens. Okay? You will never know the customer. So what you will do is you will manufacture these pens and send it to retailers in the hope that they will be sold in a certain time. So those two things are going to be important to distinguish make to order and make to stock. Make to order means that somebody has ordered and you fulfill that order. Make to stock means that you don't know the exact customer. There are some potential customers around, and you are going to basically serve in the market. Hopefully, the customers will come and pick it up. Okay? Now, these are two different settings. Of course, we all want to have make to order. We want to have the customer, but in reality, it doesn't work that way. Okay? Sometimes you have to make it for inventory, as we call it. So this is actually a system of that sort. So the production planning is you have orders coming in. How am I going to make the manufacturing, the production, so that I will be able to fulfill those orders that come in from Turkey, from Canada, from different parts of the world? Okay, so this is basically what we will hear in the beginning. So they have this so-called KISS system that does it for them. Of course, this is a commercial. So we're not talking about an engineering skill being taught in this video. It's just a commercial. So who are responsible for making a program, a system like KISS? And who is responsible for running that? Mostly industrial engineers. So hopefully in the next 3 years, you will learn enough material to put in a program like this for different manufacturing companies or different service companies. Any questions? Okay, I am aware that the voice is a little bit low, but I think if we just keep it silent as if we are watching a movie, it will not be very difficult to follow. Questions? Okay.
The system has to make sense of all these orders, different types, different delivery dates. BMW uses a special program for this called KISS. Sounds nice and friendly, doesn't it? The KISS system is based on barcoding. You know, like the barcodes you get in shops. Each car is given one of those, and it can be scanned at any time. This means it can be tracked through the factory, and it can be checked to make sure it's the right type, the right colour, and so on. So that's how they plan things. How do they make them in it? This is where the basic framework of the car is put together.
So we are entering the actual factory now. It was the planning department before.
The basic panels are made in Swindon and Solihull. They're sent into what's called body in white area, where they're put together. Why robots? There are 228 robots here. They do welding, they put glue on, they can measure and control parts exactly. They don't get tired and they don't take tea breaks. They do get dirty from time to time, which is where, check this out, they clean themselves. Now, is that cool or spooky? I don't know. It takes about 6 hours to put the basic shell together. It's made up of 350 panels held together by 4,500 spot welds. This is the underframe assembly. After that, they put all the other bits on.
Okay. Now, the first group of operations that we have seen are about shaping the body. So they call it white because it's basically colorless in the beginning. So they are going to paint according to the demand. But they are simply, the first part that we have seen is a group of operations which are instrumental to set up the body of the automobile. Now, you can see that with the process charts that we already know, you can actually write the operation of each robot one by one. Am I right? They are not doing necessarily the same thing. Okay? And so we can actually write all the operations of the robot. Now, up to this point, we thought that only humans were what we cover in process charts. No. Of course, you can do the same thing for the robot. Go take this part, weld this, and put the bolt over there, take the nut out, and so on and so forth. So you can see that actually doing this requires a lot of prior knowledge of what's going on, processes, so on and so forth. And those processes, partly you are going to learn that in some courses that you are going to see in the second year. So the idea is that we already are aware that if we had the technical background, we can formalize all the information which is given at this part. Note that robots are doing it. Now, do you think that we have robots in Turkey as well? Any ideas? Yes. I'm a robot. Well, yes, the answer is yes, actually. Most of our factories in the automotive industry have lots of these since early 90s, actually. So this is not a very enormous technology. Most of the universities, if you go to the proper department, you can actually manufacture a small robot in one of the courses in the 4th year, of course. So this is something which is known, but I think it is efficient in a certain number of ways. Now, one thing that I should ask you to give attention is the cleanness of the environment. Okay? Now, usually we have an understanding that if we are doing manufacturing, we're talking about dirt, oil, and lubricants all around, smell, and so on. It turns out that factories nowadays are very clean. A very good example, there are very good examples around Ankara as well. The first time that Arçelik dishwashing machine factory was set in Ankara, that was, I think, in 1993, 1994, it was selected to be the cleanest organization, the cleanest work environment. It was manufacturing a lot of different things at the same time, but you can always do it. It's not only a function of robots, but this is something that you have to keep in mind. Okay, any questions? Okay, let's move then.
process. Spotting any problems before the shells go on to be painted and made into real parts.
One of our main quality controls is testing the quality of the spot welds, and we use ultrasound to do that test.
Isn't that what they use when you have a helmet?
It's a very similar process. We use a high-frequency sound signal, which is sent into the weld to make sure that the weld is good.
And what exactly are you looking for?
We look for porosity in the weld, to see if the weld's cracked, to make sure the panels are stuck together properly, basically to ensure that the weld is sounding good. If we didn't make these tests, potentially a vehicle could be out on the road, a customer have a crash in that vehicle, and the car falls to bits, and we don't want that to happen.
No, definitely not. So how many times do you test?
We continuously test these spot welds throughout the day.
What, every single one?
We do test every single weld, not all at the same time, but as the car moves through the production line, we test different welds at different times, and throughout the period of the production shift, we test all of the spots.
And there's another kind of test they do in body in white, which is to test the geometry of the car. In other words, to test it's exactly the right size and shape.
We use a series of lasers that reflect off the body, and we measure to within half 100th of a millimetre the precision, the accuracy of the body.
Oh, it's scared of technical, what do you mean by that?
Well, basically, it's half the width of a human hair. We make sure all the parts are aligned in the right orientation, in space, relative to one another, and then we weld them together.
Why is it so important?
It's important because when we send our body shell to the trim and final assembly building, they need to fit their components to the Mini, to the bits that you see, the seats and the cockpit and the steering wheel, for example.
And it's got to fit completely.
Exactly. If it's the wrong size and the wrong shape, then those parts won't fit.
Oh, really? Mad?
Mad.
Okay, quality control is an essential part of the manufacturing. What they are actually doing in quality control, they are making sure that the welds that they have done, the drills that they have around so that they are going to use it later on are in the correct location. Now, of course, you can say the following. Robots are not going to make mistakes. They are not like humans. Well, it turns out that you also have mistakes that are made by robots. Because robots usually have they have to center themselves in order to take certain measurements. Now, humans do the same thing as well. You use a ruler, but robots are not going to be able to read the ruler. So what they do is they position themselves at certain point, and given that coordinate, they are going to do the welding accordingly. So they are going to select the point, which is like, let's say, Y 25 centimeters away and X 10 centimeters away. So that's the location of where they are going to work. Of course, they sometimes misposition themselves, robots, although they seem to be very sturdy, and they make mistakes. So the only way to understand that there are certain mistakes is to make quality control. Now, of course, I think, if I am not mistaken, they are not controlling 100% every body that they manufacture. Because basically you can take a sample rather than doing it one by one, and statistically you can show that you are doing a very good business. Now you're going to learn techniques of quality control in a course that you are going to see, I think, in the 3rd year. It turns out that the number of automobiles to check or to go into the quality and so on is a matter that is usually dealt with by industrial engineers. So we are going to have a course on quality control only in the 3rd year. It is a very important issue. It brings down issues of statistics. It brings down issues of conformance. And there are other things that you are going to learn in that course. So this is something that is extremely important. Of course, in automobile, when you are driving, it becomes important because basically it is a function of the safety that we have on the road. But some of you may remember certain movies of nuclear plants, like China Syndrome. Do you remember that? Anybody who knows the movie called China Syndrome? 3 Mile Island? Have you heard? The nuclear plant in 3 Mile Island? You see, the quality control is not a very cheap issue to carry out. You have to make sure that you pay enough money to do that quality control. If in a nuclear business you don't do that, then you're going to have a disaster, probably, with some probability. Okay, questions? Okay, we can go further.
So, this is the next stage, the paint job.
The way a car paint is painted is in a similar way that an actor or an actress puts their makeup ready for a performance. Really got to start off with a good scrub of soap and water. So we do very much the same here. Take the car bodies that come in from the body light department, they cover with oil and grease and dust. And the first thing we do is wash the whole car body by dipping them into giant tanks of detergent to give them a good wash.
But you can't just slap the paint on. There's all sorts of other stuff they do. They seal the joints. They put on something called surfacer. And the underbody gets a special protective coat. Only then do they put the body colour on. They put a clear glass coat over that. And then, finally, go to wax. And you can have the roof in a separate colour if you like.
Yeah, I think Mini's the only car that has a separate coloured roof. It really goes from the Mini Cooper days when John Cooper was racing Minis and had the roof painted special. I think you can see it on the Monte Carlo or the Italian jobs. The Mini Coopers have always had a coloured roof, and we've carried on in that tradition.
But it's quite a complicated process.
We mask up the entire outside of the car, leaving the roof separate, then have 4 robots that then paint the car either black or white, and then have to take all the masking paper off. So it's a very intensive process from a manpower point of view.
Each car is painted according to the customer's original order. There's no need for batches of red cars followed by batches of white or whatever. They can change colours all the time. Quality control is important here too.
Dust and dirt is one of the biggest enemies in the paint shop. You can have a lovely paint surface, but it can be spoiled by, say, having an eyebrow or a hair in the paint film, and then in that case we have to respray that entire panel to get rid of that defect. So one way we go to minimise dirt and dust is people wear these blue suits that you might see walking behind me. And they also have these layer of conducting material in there that gets rid of any static charge, because if the suit builds up with static charge, it in itself can be a source of dust and dirt. We also have other checks to make sure we're applying the correct thicknesses of film. Also, as the cars are baked in ovens, that we check the right temperatures applied. On top of that, we send panels away to a laboratory on site here that then check the paint film performs adequately for things such as resistance to corrosion and also moisture.
Now come on, they can't get it right all the time. You must make a few mistakes now and then.
We have had the odd car that's been painted the wrong colour. We use a lot of electronics in the system, and sometimes as the data is transferred from one department to another, it can get corrupted or lost. And in early stages, we did have a couple of cars painted the wrong colour.
All in all, it takes 10 hours to paint a Mini, including drying time. When the painted shells come out of the paint shop, they make their own little traffic jam here, waiting to go to final assembly. Before we talk about all that, where do all the other parts come from? Well,
Okay, just a few things before we go further. This is not going to be related to the process. Now, note that she is interviewing different people working in the factory. Okay? You can see that some people there are very lively. They explain in a very good way. But the last person was a little bit boring with respect to the voice that he had. Am I right? The voice was always had the same tone and so on. So I can see that you were sort of like looking at, your interest was lost. Now, this is very important because if you are going to do a project for, let's say, Mini, forget about working there, but just a project, you have to interview a lot of people. You can see that people have different approaches to talking, different approaches to describing, and fortunately or unfortunately, you also have the same thing in the classroom as well. Now, we're going to see how to get good information without being affected by the style. Okay, we're going to have a class about that as well, because basically our job is to interfere with, to interact with humans and get some information in most of the cases. Okay, so this is important. You can see that you can look at yourself, and when you are describing something, you may be able to select which one you want to be, rather than stay as is. Okay, I think it is important to look at it this way as well. So now, she asked the question, where does all these parts are coming from? They have a different number of parts. So let's hear that.
I can tell you, they come from all over the world, and they're stored here. This is the Integrated Logistics Centre, another word for a great big warehouse, and I mean big. It covers an area of 20,000 square metres. Huge! Over 200 different suppliers are used in the production of the beer. Only about half of those are in Britain. The engines are made in Brazil, the tyres come from Europe. They're part of globalisation. Well, this is it. But it's no good ordering loads of parts and hoping for the best. Order too few, you run out. You can't make any use. Order too many, you're wasting money on stuff you don't need. So they use a system called just-in-time. So Rachel, could you describe what just-in-time is?
Yeah, just-in-time works by letting a supplier know which parts we need to build the next car that we're going to build. We send them a sequence, and the material arrives just in time to build the car.
Before just-in-time came in, manufacturers would have to guess how many parts they needed and store them until they needed them. But it was inefficient, it wasted money and space.
If we didn't have just-in-time, there's a possibility the warehouse wouldn't be big enough. All of the material would be here, we would waste our money on that material, and also it could lead to health and safety problems.
Is just-in-time linked to the KISS production system?
Yes, it is. The KISS production system takes the customer orders and turns them into a material planning schedule. We therefore get the material from the suppliers and it arrives here in the warehouse just in time.
A good example of JIT is in the cockpit basis. The suppliers in Redditch are given just 6 hours notice before the bases are needed on the production line. It's not very long though, is it?
No, it's not. The suppliers are on a constant transport loop and they're continually building cockpits. As soon as those cockpits are ready, they put them on a vehicle at Redditch and they're shipped down to us and they're received directly to the manufacturing facility.
The KISS system controls what parts are needed when. They're transported into final assembly via these tunnels.
Okay, one thing which is interesting is that that warehouse that you see is not different than the warehouse of a supermarket. Okay, in the supermarket, individuals go and buy the items, whereas here, a production order comes and somebody picks up certain items to take it to the production, to the final assembly. Okay? Of course, you can say that the arrival of the customers are better known here, in this case, but in a supermarket it is less known. But the storage space allocation, the way that you plan the storage space, is exactly the same as a supermarket. Okay? This is very important to understand. So we're talking about a manufacturing system, but there is a supermarket in that manufacturing system which does certain jobs and which fulfills certain requirements. In a supermarket, you also have a lot of goods that are coming from overseas, from other countries, and so on, imports and so on. And here it's exactly the same. Only the customers are not very well observed here. They are simply numbers. A certain number comes, and so you fetch the parts that are required for that customer. Red roof or a different type of the wheels, different carburetor, and so on. You may order different things. So it will be placed according to your wishes. It's like a supermarket car where you place the items that you want to buy. But you are not there. Okay? So that's the main difference. Your number is there, and your number is collected accordingly when your time comes. Okay. So this is, I think, the most important part. We're going to talk about this later on in other lectures as well.
All a total of 2,415 parts are added at the final assembly stage. That's where we are right now. So this is where a mini really gets to look like, oh, a mini.
So this is the final assembly line that I was talking about.
And this is where all the customer choice elements start to show up. The colour combinations, choice of wheels, sunroof, left-hand drive, right-hand drive, and so on.
That goes on there, like so. Oh, like I can't made a minute. But like I'm contributing to a minute. Never buys that car, worth a fortune.
And of course, it's still linked to the KISS production planning system. Now there's a barcode which contains all the information for this particular car linked to its original order. So you can check it's got all its bits. It's also a way of monitoring each car through the production process. The doors, in fact, are taken up again. This makes assembly easier. They're put back towards the end of the process. There are so many different types of tyre you can have. It would be dead easy to put the wrong ones on the car. This is where the checking system comes in.
So Lee, what's your job here?
When I do the wheels and tyres, I have to put the right tyres on the car. I need to set it go on the track so they're in the right order to go on there.
Okay. You have to do the sequence, is that
Yeah.
right? Why do you have to do that?
Well, because if it goes on that day wrong, you're going to go over the check. It'll go down and then they'll have to stop the line to get the right tyre for it.
Okay, is this machine correct?
Well, what it does is, it'll come from here.
Yeah.
It'll take a picture of it.
Okay, so British working class, actually. Hard to get it, the English, of course. Our English is very academic compared to them.
The right tyre job.
Quality control is still vital.
Just taking the car off the end of the track.
Yeah.
And this is the deck sheet. This is what a customer orders. And anything on here, I check to see it's on. Once I've done this, I'll then look around the car.
Okay, let's go. This is called a sector audit. It's where they check that all the bits on the car are what the customer ordered.
Every car we fit has got a number. Yeah, and then, sorry, I'll check this list.
Yeah.
Steering wheel, rear spoiler, check the rear spoiler, white one, white one. And once I've gone through this list, I'll check that I've fitted every label correct.
So is that right?
That's right, yeah.
In the past, assembly workers weren't encouraged to think about their jobs. They just came to work, did their bit, and went home again. These days, people work in teams. The idea is that workers manage their own work and solve their own problems as far as possible. Continuous improvement is another important thing. It's not enough to keep the same standards. How can things be improved? This is what this meeting's about.
One of the problems that we highlighted was the amount of litter on the skillets going through glazing. And in the space of approximately 24 hours, we probably get 1 or 2 light gauge trips just due to litter being on the skillet. So what we did yesterday was we replicated the skillet transfer system, what we've got in drop section 7 to drop section 6. We put it in yesterday afternoon. And yesterday afternoon we put it in, this is in the past 24 hours. That's where it picks up just out of the boxes at drop section 7 in the past 24 hours.
And sometimes there's some pretty hard talking.
Yeah, it's been done, and it's been presented, not even considered a practice from home. So it's me as a team leader, I don't promote it up beyond work. Until I get recognition for it, I'll promote it on work.
So the usual way is that they would propose a change, and then the engineers would check, look at it, and maybe implement the change. That's the way that it goes, actually.
Well, for 2002, Plant Oxford registered over 10,500 ideas, and out of that, over 8,500 were actually implemented. So we're working on a ratio of about 84% at the moment, and those ideas actually generated over £6 million in financial cost savings for the plant. So we're actually very pleased with what our people are doing, and we recognise the value of those teams to the business.
Only 4% of the ideas are implemented.
Health and safety is very important. Certain areas require protective clothing and equipment. This is a legal requirement, as well as being a good thing to do. In the old days, the tools were mostly powered by compressed air. It was much noisier. These days, it's mostly electronically operated tools, which are also more accurate. The moving floor of the production line is deliberately flexible. This is less wearing on the knee joints. The factory is laid out to minimise the amount workers have to lift things. The height of the car in the assembly line can be altered. This minimises the amount of bending or stretching when parts are being fitted. The rotary sling actually turns the car around so that assembly workers can work easily on the inside. So, the Mini's pretty much finished by the time it comes off the line at final assembly. There's still a lot of last minute checks and tests to do.
It's not real. No. It's not on the road, don't worry. Or worry, I don't know. Or be happy.
And there's one final test. Does it go?
Okay, I think this is sort of coming to the end. One note before we take the leave. Remember the health, safety. For example, they said that you shouldn't be worried about lifting heavy things and so on. That's the role of traditional industrial engineers. Traditional industrial engineering in the 20th century have done a lot of work to do that. We don't have any traditional IE courses in our faculty anymore. I will talk about that. Okay.
But then I thought about all those parts coming from South America, from Europe, from all over. Global production seems efficient. What is the cost of pollution transporting all these parts? And then, when the cars are made, they're sent back again, all over the world. I thought, hang on, something's a bit wrong here. BMW are very clever people. Lots of people love aluminum. How clever is it to send all these cars out, hundreds every day, just so they can sit in traffic jams? Because that's what cars do these days. Climate change is now officially recognised by the government, and it's caused by global warming. Cars are a big factor in that because of CO2 emissions. I mean, I love cars, but how many do we need?
Okay, I think the last part is important because it gives a global picture of automobiles. Now, we are, as engineers, interested in the details of it. You can see that, but there are some other issues which we have to confront either in our daily lives or even at the workplace. Now, those are very important issues because you are not only going to become an engineer, but at the same time, we are hoping that you are going to become good citizens. Citizens who are aware of these type of factors, which is a little bit beyond your own discipline. So there are certain courses that you will be allowed to take, and it will be in your curriculum as well, which is going to give an understanding of this global picture, although unfortunately engineering is more narrow when you look at that global picture. So this is the way that actually they end the video. Most of the companies are spending some money with respect to improving their operations with respect to some measures like global warming, so on and so forth. Okay, questions? We're going to start after 10 minutes with some discussion, and then we're going to talk about another technical problem, which is called the assignment problem.